Good afternoon, everyone. Together with Brandt Consolidated and behalf of the team here at Evenspray, I'd like to welcome you to today's webinar. Just so you know, we will be recording the webinar. Speaking to us today and sharing their wealth of technical knowledge and wisdom on the subject of photosynthesis is Dr. Arthur Nonomra, and later on we'll be joined by Mike McBride. Dr. Nonomra is the Senior Vice President and Chief Science Officer for Brandt Hammer. He has devoted his career to helping others through science, and to that end, has developed innovations that promote healthy plants and healthy people who grow them. He's worked at University of California, Berkeley, the University of California, San Diego, Harvard, and most recently at the Northern Arizona University. Mike McBride is the president at Brandt Hammer. He was previously a superintendent for 23 years at the Jack Nicklaus complex. He worked with Arthur to develop the flagship products that Hammer offers. So without any further ado, I'm going to turn it over to Dr. Nonomra.
Advances. Okay, glad to meet all of you. Thank you for joining us. And let me just tell you what you will learn. I've got to get rid of this sidebar here. Okay, so what you will learn in this is photosynthetic processes. The title is How They Are Mastered for Optimal Productivity of Turf and Ornamentals. And this is a product of having a powerful new tool for photosynthetic biochemistry. And they may sound like a lot, but what we're going to do is tell you what you will learn. You cannot hold light in your hands, but sunlight is delivered to Earth every day, and in all turf, that light is transformed into substance, the substance of life, that you can construct golf courses with, you can wear some of these substances, you eat these substances. Life uses light that is transformed into substance that you can hold. Here you will be given up-to-date fundamentals of photosynthesis with a new understanding of how to gain control of it. Our format will be to identify problems that we all face when managing turf, and we will solve them. We'll offer you some solutions. To be true of life's energy transformations, photosynthesis tops the list. So, to begin with, let's talk about what we mean by transformations. So, here's the problem, our first problem. What's transformation? And the solution is this. You may be familiar with the transformers. So, turf's crucial energy transformation, like the transformers, is that light energy is transformed into chemical energy. This has actually been the greatest advance in life sciences of all time. So we have our first test question right up front. Photosynthesis in turf transforms light energy into what other form of energy? And the answer is photosynthesis transforms light energy into chemical energy. That's your first test question of 9. So plants receive light as photons, which are basically packets of lights, It's a photon is a unit of light. And plants receive these photons and eat light, yet golf courses present challenges of availability of photons of light. The first problem that we face is that overcast days often run into weeks of deficiency of light, photon deficiency. There's other problems with photon deficiency. You have daily shading and elongating shadows that limit light, affecting turf quality. And the big problem is that you have too few photons, too little light. For example, here is the country club at Muirfield Village. The number 10 green is shaded, and actually 3/4 of the green is shaded just about every day. So the solution that you have for it is, after treatment with photosynthesis nutrients, turf quality in this shaded area soon became equivalent to the greens with full sun. Okay, so the problem: trees absorb photons. Trees shade. Trees absorb the light, or sometimes they reflect it. The solution is to manage photosynthesis, and you may not need to chop the trees that are creating that shade. Of turf's energy transformations, the most important is photosynthesis, for it is this process in which light energy is transformed into chemical energy. Now, this is typical of what you see in a classroom. In fact, we've sent 1,000 of these posters of the Z-schemes to classrooms, but let's keep it simple by using a golf analogy for the Z-scheme. So the problem is really, who gets this? The Z-scheme, as you see to the right in the screen in yellow, is a graph of the electron energy level, and we show at the top of the graph the EM scale, the electron energy level scale. So light energy splits water and energizes electrons for transport, and that's what this shows. And to the left, you see another form of the Z-scheme that's greenish, and that you can kind of trace that black line in that left diagram showing green, and that's actually another way of depicting the Z-scheme. But it's really difficult to understand because this is all biochemistry and also light chemistry, and we're just trying to figure out, how do we find a solution to who gets this? And the solution is that electron transport is like a backspin wedge shot. Our analogy for electron transport is this backspin wedge shot, where the electron is the golf ball and the energy that's being put into that is from Chris Zinna hitting it. As the golf ball lands and spins, it loses energy, just like the electron in the Z-scheme. The putt adds energy to hold the ball. Similarly, in the bottom leg of the Z-scheme, light energizes electrons for transport to NADPH to carry chemical energy to turf growth. So we're at test question number 2 of 9. And this is what we just described. Light energy is utilized to split water to release oxygen gas and to energize electron transport as charted in the Z-scheme. So the question is, what golf shots explain the Z-scheme? And the answer was not supposed to show up, but now you have the answer. The golf shots that explain the Z-scheme are the backspin wedge shot and the putt. In photosynthesis, light energy is transformed to chemical energy. And to do this, the process relies on the essential plant nutrient elements that the reactions in this electron transport chain rely on. Furthermore, you can manage the rate at which turf eats carbon to proportion the metabolism of essential nutrient elements with photosynthesis fertilizer formulation. For example, superintendents take the reins by managing photosynthesis in the field with Brandt Hammer Advantage. It's a 501 and micros formulation because it is packed with the right amounts of nutrient elements that are essential to photosynthesis and that are often deficient in golf courses. Therefore, what we look for is the essential plant nutrient elements, which are shown in the chart. This green chart shows that you have first nutrients from air and water, CHO. Then you have the macronutrients or primary nutrients such as NPK. And then you have your secondary nutrients, calcium and magnesium and sulfur. And finally, you have your micronutrients. And these include manganese, chlorine, zinc, copper, nickel, cobalt, boron, and molybdenum, and iron. With the exception of boron and molybdenum, every one of these essential nutrient elements is actually involved in this electron transport chain in the light reactions of photosynthesis. And when they are used in this electron transport chain, that part of the star that we perceive as light is on its way to becoming substance that you can hold. So, test question 3. Photosynthesis cannot work without the essential plant nutrient elements. Name at least 10 nutrient elements that are essential to the process of photosynthesis. And your answer is take 10 out of any of these and you're good to go. If you didn't get them down fast enough, just look at the show again that's being recorded. All right, the light reactions of photosynthesis that we just talked about in the Z scheme run simultaneously with the carbon reactions of photosynthesis, by which chemical energy is incorporated into the bonds that hold sugars and other carbohydrates together to make food. I worked with these 3 giants of science and actually collaborated with them on 7 of the Nobel series called The Path of Carbon in Photosynthesis when I was working at University of California. So these include Andrew Benson, who I worked with closely together for 30 years, James Al Basham, and Melvin Calvin, who is the Nobel laureate 1960 in chemistry. What they found was that Benson, Basham, and Calvin, there's actually a cycle named after them, the Benson-Basham-Calvin cycle, which you may know as just the Calvin cycle, but properly it's called the Benson-Basham-Calvin cycle, and it runs in the chloroplast. And what they showed was that carbon that builds turf comes from air. Carbon dioxide is captured, and that's that little blue and black figure, is captured out of thin air by the enzyme rubisco. And this is actually a model of rubisco that is generated. And so it's a cylinder, and carbon dioxide is fixed to rubisco, not directly, but it goes through one step before that, and we know, but carbon dioxide is fixed into 5-carbon compound, making a 6 carbon compound that is split to 3-carbon compounds. And that is what happens when carbon dioxide is fixed. Oxygen also competes with carbon dioxide for rubisco. So when oxygen actually outcompetes carbon dioxide for rubisco, then it runs a process called photorespiration. And that actually consumes energy rather than fixes energy. So we'll leave that aside for right now, because photorespiration, the symptom of it in the field is midday wilt. So this brings us to test question number 4. Trying to find my cursor. So test question number 4 is photosynthesis in turf works in 2 simultaneous reactions. Name them. You have the reactions of photosynthesis and the blank reactions of photosynthesis. So the answer is the light reactions of photosynthesis and the carbon reactions of photosynthesis. As you saw in that chart of essential plant nutrient elements, C, carbon, hydrogen, and oxygen are essential turf nutrients, and these come from air and water. In the carbon reactions of photosynthesis, chemicals are joined to make sugars. Regard this as turf's job. Actually, it's every plant's job. Carbon dioxide gas in air is captured by rubisco. Sugar is made by adding 1 carbon per turn. And sugar is a simple carbohydrate. Now, what you can look at is, and this is that carbon dioxide plus water makes your carbohydrate. So C in carbo stands for carbon. So it's carbon and water, carbohydrate. So this brings us to test question number 5. Which gas and liquid do plants eat to make carbohydrates? The answer, carbon dioxide, gas, and water. And this is just for fun, since you are involved in turf, which is a grass. You know that turf packs chemical energy by way of the carbon reactions of photosynthesis. I discovered how to manage carbohydrates to control release of sugar energy in the field for resistance to abiotic stress and to grow. The most enduring abiotic stress is recovery from midday wilt that improves resistance to foot and cart traffic. Control of the carbon reactions is a new tool of science based on trapped carbohydrates in the native protein lectin. So this is actually an update that you will not have received in your classroom. And the problem is that turf has proteins in them, a lot of proteins called lectins. And these lectins trap sugars and other carbohydrates. And when they do trap these sugars, they render the sugars inert. And that's a diagram of the lectin cycle. The solution was, that I discovered, was to induce a carbohydrate bypass, a sugar bypass, basically, for efficient utilization of sugars by the entire turf plant. And I'll show you what I mean by that in a second. But the problem that turf has of trapping the sugars is akin to native lectins that are like a trapdoor spider. Spiders that trap food and store it end up just taking in the food and storing it, similarly to lectins that are taking the sugar in and they bind it. So we have actually a plant growth regulator for photosynthesis, and we know the mechanism of action very intimately, very well. Alpha-methylmanoside in this case occupies the binding site when we spray it on, and it locks out and excludes glucose. So we have induced a bypass of the lectin cycle. And so instead of just being inert glucose on these lectins, glucose goes to plant growth points, to respiration, to homeostasis, to turgor, and to flavor, and to everything about the plant, because this is your photosynthate, main photosynthate that achieves, when we induce the bypass, it achieves freedom. So when you have an inert sugar, what you're trying to do now by inducing the bypass is find a way to make them active again. So when glucose binds to lectin, it is osmotically inert. But when we treat the plant, our treatment occupies the lectin and it forces glucose and other sugars to leave. The free glucose in a cell accumulates, and that increases turgor because now it's an active glucose molecule, and the vacuole presses against the cell wall, and then the cell expands. So you have an increased turgidity, and the ultimate result is that you have recovery from midday wilt because you have a highly turgid plant. So we have our next test question, question 6. Soluble sugars maintain turgor by pressing the vacuole against the cell wall. This aids in turf's recovery from midday what? And the answer is, this aids in turf's recovery from midday wilt. So this sets us up to a problem that carbon and nitrogen assimilation are integral. Therefore, during midday wilt, you end up with low carbon assimilation and low nitrogen assimilation. The solution is to induce the bypass and recover from midday wilt for nitrogen use efficiency. So in the graph down below, the schematic you see below, when you have high carbon assimilation, then you can actually feed the plant a lot of nitrogen to offset the carbon assimilation. Actually, it goes hand in hand because carbon and nitrogen assimilation are integral. So when you have a higher degree of carbon assimilation, then you can actually assimilate nitrogen, and you have a really solid nitrogen use efficiency. And the result of both carbon and the integral nitrogen assimilation, you end up with being able to make the plant to be able to make amino acids, proteins, DNA, RNA, and other nitrogenous compounds that grow the plant. The field effect of this is that fertility of Tiff-Tuff Bermuda graft in a field confirmation by Henry in 2016 at University of Georgia showed that you actually get improved nitrogen use efficiency when you treat the crop with a Applause Plus at 3 fluid ounces per 1,000 square feet. when you add a nitrogen source such as ammonium sulfate, you get an increase of nitrogen assimilation. And this is just great academic confirmation. So carbon and nitrogen assimilation are integral. You manage the rate at which turf eats carbon and nitrogen with our photosynthesis technology. Carbon and nitrogen assimilation are integral. That is, they go hand in hand. Growers take the reins by managing the flow of carbon, and managing carbon and integral nitrogen assimilation results in high nutrient use efficiency in the field. So let's reduce this down to an executive summary that you can go up to your board with. Turf eats carbon and nitrogen and other nutrients. Carbon and nitrogen are eaten inside of plant cells. Carbon and nitrogen assimilation are integral. It works internally for 3 weeks in the field, and you can manage the flow of carbon in sync with nitrogen. Integral carbon and nitrogen assimilation is achieved by application of our precision formulations. So this brings us to test question number 7. It's multiple choice. Carbon and nitrogen assimilation are, take your choice, A, integers, B, the metaverse, C, resistance is futile, or D, integral. Did you make your choice? The answer is D. Carbon and nitrogen assimilation are integral. They go hand in hand. You can't separate them out, but you can use that integral nature of carbon assimilation and nitrogen assimilation to your advantage in the field. Photosynthesis builds both roots and shoots, including the leaf blade. Deep roots reach down in the ground to water and fertilizers. They're just sitting there, might as well use them. The root system on this putting surface became 13 inches long. And those roots were able to access deep water and minerals after a couple of seasons of treatment with Megalex or Advantage. Now, what's important about this is it takes a couple of seasons before you get results like this, at least a couple of seasons, because normally you have maybe 4 or 5 inches of root depth in your greens, but after working with these formulations for a few seasons, you can actually get these long, deep roots that access those deeper water, moisture, and minerals. And that sets up the plant for really good active transport. And that contributes to turf quality, because active transport across the plasma membrane is the rate limiting step, and you can optimize transport by inducing the bypass that we talked about. Thus, tank mixes for high efficiency IPM reduce inputs and outgo. Photosynthesis works hand in hand with integrated pest management of midday wilt. So when you manage midday wilt, it strengthens and enhances turf quality, because the turf blades are just standing up. Healthy plants attract fewer pests than weak turf. So it's important to optimize active transport, also optimize the turgidity of the plant with to manage IPM and to work with pesticides. So it brings us to test question number 8. And this is actually pretty straightforward. How do you access deep nutrients and deep roots? How do you access deep nutrients and deep roots? You increase photosynthesis, because photosynthesis builds both roots and shoots. Deep roots reach down into the ground to water and can grab more water. And they also will pick up the fertilizers that were overdone for many years. There's a huge well of fertilizers down there. So you can use less fertilizers and less water after a couple of years of getting deep roots. So golf courses are all about photosynthesis. You're surrounded by it. It's the most important and transformative process in your golf course. So what you often see, and we've seen, is that in greens and fairways and landscape, you have problems with quality. And the solution to this is to do spray applications of Advantage at 3 to 6 fluid ounces per 1,000 square feet, Megalex at 3 to 9 fluid ounces per 1,000 square feet, or Plus at 1 to 2 gallons per acre, mainly on the fairways. You use these products to manage photosynthesis, because that's what they do, by feeding the photosynthesis essential plant nutrient elements to accelerate plant tillering, to get compact, healthy plants, to get rapid rooting and deep rooting, to get impressive color, quality, and vigor, and to get consistent green speed. Advantage is actually is our flagship product, because it has the major and well, it has primary, secondary, and micronutrients. Megalex has some of that, but it also has a very high carbon to nitrogen ratio. So it actually is very good for maintaining consistent green speed on your greens. And Applause Plus has a high nitrogen content and some nutrient elements that are usable for getting good growth on your fairways of the top growth. So you have this whole system of different nutrient elements in it that will encourage the photosynthetic growth of the plant. And you also have the instructions on the bottle to how to use them for different situations. So in sports turf, in golf courses, and in all the trees and bedding plants that you have in your landscapes, you can optimize your turf quality by managing photosynthesis, because these are all plants that you can control the growth of, that you can control photosynthesis to resist stress, to stand up to traffic, and a whole lot more. Tamarack is a really good example up in Ontario. And the problem that they had was their water pump went down. It's a low budget golf course with an old diesel irrigation pump. And for some reason, the pump did not irrigate the greens properly. So they ended up with that example on the far left of greens that just were not very good at that time. And this was back in June of 2017. We sent our guys up there on June 9th, and they recommended that it is first treated on June 11th. And by June 20th, you saw a rapid improvement of the those greens. They actually could have used it, but they found that by July 20th, you had nearly full recovery in Tamarack Ridge. So the Tamarack green, in this case, recovered quickly after bi-monthly treatments from June 11th to the 20th. And if you'd like more details of that, you can ask Mike at the end of this, just a few minutes. So what's important to you superintendents is that you can make the case for cultivation of turf. And this is really important because golf course superintendents must relate the essence of their turf requirements, and that is photosynthesis, to the golf committee. So now we're trying to give you the tools on how to make this presentation to your golf committee, that you need the proper nutrients, you need the proper treatments to cultivate turf and end up with really high quality greens and fairways and landscaping. So life transforms light energy from our star, the sun, into substance that we can use for work and growth. Think of carbohydrates as you would a battery. Energy that is transformed into the carbohydrates, such as sugar, can be stored, transported, and consumed. Starlight is transmitted to Earth in waves of photons, these little packets of light that are made up of energy and mass, of small, the tiniest amount of mass. And that's what these photons are. In turf, light energy is transformed into substance, and that's what we call chemical energy, by way of the light and the carbon reactions of photosynthesis. So in conclusion, we can clearly state that starlight or sunlight is made into a plant. So this brings us to question 9, our last question. When you touch a plant, where did the photons that energize the plant come from? And the answer is the sun. It came from the light energy of our star, the sun. And we can conclude then, since the plant is made of starlight energy, when you touch a plant, you are touching a star. You eat a plant and you become the star. As you're made from plants, so are you made from the stuff of stars. So in conclusion, light energy is transformed into chemical energy, as we've been saying. Light energy involves the light reactions of photosynthesis, the Z scheme, the electron transport chain, and essential plant nutrient elements. Chemical energy is derived from the carbon reactions of photosynthesis, where you're making sugar and other carbohydrates. Carbon dioxide and water make carbohydrates. And sugars are packed with energy in their bonds. Turf utilizes sugar energy to maintain health and turgidity. So you can now use photosynthesis, manage photosynthesis, control photosynthesis to make turf work for you, not the other way around. The Brandt iHammer product line is in a class of its own. the flow of chemical energy by treatment of crops with the natural carbohydrate product makes endogenous sugars, that's internal sugars, available inside of the cell, and that makes turgidity at a high level possible. So you can actually recover from midday wilt. It also makes photosynthesis happen and crop your turf development and productivity. The Brandt product line is safe and effective, and they're all registered plant fertilizers. They're field proven. They have patents issued. Brandt manufactures the materials in the United States, and we ship them up to Canada. The science is really far-reaching, and first-order science gives you a product with high purity. You know what's in the jug. In other cases, we see things that they don't really know what's in the jug, but in our products, you know exactly what's in the jugs, and it's based on discoveries in science of plant metabolism, of the glycocode, it's otherwise known as the sugar code, and in biochemistry. Our advancements are that we know the mechanism of action, and the mechanism is the foundation for biorational design, and that's the basis of all of our products. You can use our products either on foliar applications or root applications, and you will be working with the essential plant nutrient elements. The products are all compatible with auxins, cytokinins, virtually all plant growth regulators, including herbicides. It's compatible with fertilizers and pesticides. So here we have our final problem just to look at. It's not a question, but this is a really good example of the Findlay Country Club greens. This was actually treated a long time ago, back in 2005. And what we found was very quickly, we moved from inconsistent quality, inconsistent green speed on their greens. And the solution was to treat them with our fertilizers, and we have consistent green speed now and excellent quality of the turf. You may be asking, what does this cost? And for that, you can check with Mike, but it's very well documented that you're getting healthier turf. That means better playing conditions and really happy golfers. And part of the happy golfer equation is that when you have less stress on your turf, it also means that you have less stress on your superintendent. And so you have a happier superintendent, happy golfers. And when you have management of photosynthesis, you optimize your turf as compared with any control, that you have better color, you have improved turf quality to the point that you can actually play tournaments and put it on TV, and you have excellent health. All right, so I showed you the Z-Scheme poster. We also have a poster for the plant growth regulator for photosynthesis, which is a product that's not rated yet for golf courses, but it's a good poster to have around to show how to induce, how you are inducing the bypass of the plant lectin cycle. So we show both the lectin cycle and the bypass that you'll be achieving with the Brandt fertilizer products. So we can provide these If you just ask Darren, he'll get back to us and get you any number of these posters that you wish to have. Our references include peer-reviewed, high recognition and high impact plant journals and photosynthesis journals that are internationally recognized. And there are peer-reviewed. So there's everything from 2018. We actually go back to the 1990s in these peer-reviewed journal articles, but you can get a hold of these also by asking Darren if you actually would like to have a copy of any of these. And you can also get a Brandt catalog from him. We've had university field confirmations, and these include University of Georgia, Ohio State University, Auburn University, Rutgers, and the list will go on as time goes on, where we are showing efficacy of Brandt Eihammer's products. When I go out to the golf course, especially the ones that I've been treating, I see this star. I see this star. It's and your star, the sun, is shooting photons at us all the time. So use your star that shines on your greens every day. Manage the power of the sun and control photosynthesis. That is, for example, maintain hydrostatic pressure to keep your turf erect, and that will result in quality turf with really good color. Photosynthesis requires a balanced diet. That is, the essential turf nutrient elements that feed the electron transport chain, that also feed the carbon reactions of photosynthesis and all other processes of the plant. And these essential turf nutrient elements include carbon, hydrogen, oxygen, nitrogen, phosphorus, potassium, sulfur, calcium, magnesium, iron, zinc, manganese, boron, copper, molybdenum, nickel, and the new addition to essential nutrient elements that we're putting forth is cobalt. Only needs very low concentrations of nickel and cobalt. And when you control the process, you get high nutrient use efficiency, and superintendents manage turf's superpower, photosynthesis. With that, you get green quality, consistent speed, firmness, and green resilience. Is this significant? Only that you're commanding the fourth agricultural revolution, and in 2020, you have control of photosynthesis that is in your golf course. Mike is working on gathering some more of these testimonials, and we're going to be putting together some video testimonials too. So, and these are people that you probably recognize their names, and although some of them are way in the Southwest, like at the club at Las Campanas in Santa Fe, New Mexico, it works across the board from northern latitudes down to the Southwest. Okay, so I think that we have some time for questions. Is there anybody that would like to ask questions? I think that you can send them to chat, or you can ask questions. And Mike is available. Mike, are you, is your audio on?
Can you hear me?
Here's Mike. Yep.
I'm here.
I know that this was a lot to take in because we're talking about photosynthesis. And actually there are updates that you've received that are not available anywhere else at this point, but I think that you'll appreciate that these nutrients involved in photosynthesis are actually, most of them, 17 of them, are already considered essential plant nutrient elements. So I'm going to stop sharing the presentation because I don't think that anybody will want to have those showing up anymore. And
Yeah, and just again, if anyone does have any questions, you could add them to the chat in the bottom of your screen.
I'm wondering, I don't know how to get that end show. Okay, good.
All right, well, it looks like as far as answering questions today, your job's going to be extremely easy.
Yeah, well, you know, the questions and answers were all there.
Exactly.
So I think that you're all ready for that. And they actually are just reviews of what I just spoke of before that. So it's really nice.
Right, well, on behalf of Even Spray, again, thank you for joining us today. Appreciate your time. Again, if anyone came in late, CEC points were available for this talk. The talk was recorded, and throughout the talk, there were questions posed and answers there for you, so you can look it over. Yeah, and still no questions. All right.
I guess, Andrew, what we'll do is for the Ontario participants, we do have a test form that we'll send out. Even though you guys do have the answers, you can just email me the answers and everything back so we can submit those to the IPM Council of Ontario. So you guys are approved for those points there. Yeah, so otherwise, you know, it was a pleasure having Dr. Nonomra and everybody here. So
Great. So go out and manage your photosynthesis on all your golf courses. We try to make it easy.
We need it to melt the snow right now.
Yeah, actually, you know, one of the ingredients in Megalex is used for ice melt on aircraft wings. So you can actually use it if you put the Megalex on areas where you want to get rid of snow quickly. You can spray Megalex on at a high concentration, and it will help with the snow melt in areas where there's turf or plants. And it will actually work to help grow the plants.
what kind of, and that's a great thing, but what kind of uniformity would it be if you're putting it, you know, out on the ice, and once it does start to melt and get into the plant, are you going to see, you know, you know, uneven uniformity throughout the area?
Well, it depends on where you're spraying it and how much you're spraying on. But if you're using Megalex, it will be pretty uniform. It will, but you will be able to see some improved color on some of these areas, especially on your landscape trees. It will be really beneficial to the trees because they'll come back a little bit better.
Good.
Mike, do you
Yeah,
have
and
a comment?
if there's any other questions, feel free. I think you can get our emails through Andrew, but get Arthur's email or my email and send us, if you have any questions directly, would be great. But we're always here to help you, and especially in Canada where your shoulder seasons, where your light or less, it can help there. And like Arthur said, the midday wilt, it makes your plants more productive through that whole afternoon phase. And that's what really is key to keeping your the turf better throughout the whole year. But yeah, feel free to email or call us. We can answer anything that to help everybody at Even Spray to get this out there so you can see some really good results.
We do have a question, I think that came in. Mike, I think you can answer this because you live in a icy area. I think Mr. Mitchell, is it? Did you have a question? It's up in
See
chat.
here, the question asked, would it melt ice late fall or early winter on frozen ground?
Well, what we have recommended in the past, and it's kind of the opposite of, if you have a dry open winter, because of the way it acts on the plant, it can help protect the plants in the fall going into winter. But if you have the application down prior to let's say a night that you may have a frost or a light snow, it will help keep that away for a longer period of time than if you did not have that down, just because of the this sugar component that's in these products that really is the active.
Just don't spray Megalux on your aircraft
Yeah,
when they take off.
if that helped. If that helped, but there is some preventative. Work that we try to do, prior to winter to help, especially Poania have short roots or more susceptible to getting some of that winter, dry wind burn. It will help those plants get through the winter.
Okay, so just to summarize here, so it's more of a preventative than a curative?
Well, when you're talking about, I think we're talking about snow and ice. We're trying, you can put it down, like Arthur said, you can put it down after the fact. That will help remove it if it's a small amount, or you can put it down prior to, that will keep the frost or a light snow away.
Okay.
It's not going to help you on a 1 foot snow. It's not going to help there, but some of these light events that it could help.
Yeah, it won't help you during this bomb cyclone that you're experiencing right now, but it will help you maintain your the health of the turf if you put it down before or at the end of the snow season where you're trying to get some recovery.
Yeah, what we have seen is with people putting down their last application for their snow mold, tank mixing any of our products, the Megalex, Plaws, or the Advantage with that actually will help systemically in the plant and keep that carbohydrate load in there so it will pop in the springtime.
But the main thing is to use it during the growth season of turf
Right,
that you can optimize your photosynthetic efficiency.
right. But it's a good, what we would all call a dormant feeding. It's a good thing to do at the very end of the season too. So using it throughout the season, then right towards the very end when the snow mold applications go down, to put that down at the last time works out well.
All right. I think we've reached 1 o'clock, so I think that we're on to the next session.
All right. Well, once again, thank you very much for being here today. If there's no more questions, I guess we can end the recording now.
All right. Thank you very
Okay.
much.
Thank you.
Eric.
Thank you.
Guys.
Have a good day, guys.
Bye.